The cracking reason your glaciers hoard earthquakes from you, and in 1964, Alaska, they released them all at once. Right now, miles of ancient ice are pressing down on fault lines that run beneath cities. Beneath roads you drive. The ice isn't melting, it's letting go, and what it releases next you won't feel coming. Most people think glaciers are just frozen water. Slow, passive, waiting to drip into the ocean. But the weight of a glacier, a real one, a full one, is so immense it holds the Earth's crust in place like a thumb on a bruise. Jakobshavn Glacier in Greenland, nearly 3 miles thick at its deepest point. That ice presses down with 700,000 tons per square meter, not metaphorically, physically. It locks faults in place. It pins tectonic plates from moving the way they want to move. And every year that ice gets thinner. Every year it loses its grip. The quakes it was holding back are still there, waiting. Here's what scientists didn't expect to find when they started mapping ice loss against earthquake data. The correlation wasn't just close, it was almost perfect. As glaciers retreat, the land underneath rebounds, slowly, invisibly, about an inch a year in some places. But beneath that gradual rise, faults that haven't moved in thousands of years are reaching their breaking point. In Alaska, the rate of significant earthquakes has increased measurably in the exact regions where glacier mass has dropped fastest. In Iceland, seismologists have documented a direct link between specific melt events and quake clusters in the weeks that follow. But the place that should unsettle you most is not the Arctic. It's not Greenland. It's the Pacific Northwest, where the Cascadia fault line sits directly beneath retreating glaciers on the flanks of dormant volcanoes, mountains that have been ice-capped for so long, no living geologist has ever seen what they look like fully uncovered. Until now. Wait, stop. Because right now you're thinking this is a future problem, something that happens in 100 years when the last glacier finally melts. But that's the trap. The quakes aren't stored for the end. They're being released incrementally, in swarms, in ways that don't make the news because they're each too small. Dozens of magnitude 3 and 4 events clustered in places that should be geologically quiet. The scientific term for this is glacially induced seismicity. But the real name, the name that actually captures what's happening, is debt collection. The Earth has been holding a balance due. Every ton of ice that disappears subtracts one more unit of pressure from that debt, and the ledger has to zero out. In 2009, a research team modeling Alaska's southern coast published findings that stopped the seismological community cold. They mapped fault stress against glacier retreat rates and arrived at a number that nobody wanted to say out loud. By 2100, the probability of a magnitude 8 or greater event along already stressed faults increases by a statistically significant margin. That isn't speculation. That's physics. When you remove 150 billion tons of ice from a fault system annually, which is the current pace, you change the stress equations. You remove the damping force. And what happens to a spring that's been compressed for 10,000 years when you slowly ease the weight off? It doesn't relax, it snaps. But here's the part nobody talks about. The quakes that concern geologists most aren't the small ones being released now. It's the ones that aren't. There are regions along the Alaskan coast, in Greenland, beneath Antarctic ice shelves, where the crust has absorbed the melt signal. Where the land is rising, the faults are reactivating, but the major slip hasn't happened yet. Seismologists call these regions locked. A locked fault under a retreating glacier is a clock. And every year that passes without a major event doesn't mean it's calming down. It means the pressure is still building. The debt is compounding. The vault is getting fuller. And none of it makes a sound. This is what ice has been doing for you without your knowledge, sitting on top of the planet's most unstable geology, dampening forces so old and so powerful they predate every civilization ever built. For 10,000 years, since the last ice age ended, the remaining glaciers have been keeping a lid on faults that humanity has built entire coastlines around. Seattle, Juneau, Reykjavik. Every city at those latitudes sits within the influence radius of glaciated fault systems, and the geological record is unambiguous. 12,000 years ago, as the last great ice sheets retreated, the planet convulsed. Mega-earthquakes, mega-tsunamis, eruptions that lasted centuries. That period has a name in geology, the deglaciation catastrophe. The models say we are beginning that cycle again. Slower this time, but beginning. So here's the question no one in seismology wants to answer out loud. If the glaciers we're losing right now are still suppressing quakes, how many are being stored? How many fault years of pressure is the planet hoarding beneath what's left of the ice? We know it's happening. We can model the physics. But the exact location of the next release, and exactly when that debt comes due, that nobody knows. Yet.